Dear second prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Geometry Unit 4, Lesson 4. The lesson called Corollaries related to the isosceles triangle. We still in the unit of the isosceles triangle. Okay, now we have three corollaries related on the isosceles triangle. Let's start the lesson. The axis of symmetry of the isosceles triangle. First, what's the meaning of the axis of symmetry? We studied many times the meaning of the axis of symmetry. We know that the axis of symmetry is a line that divides any shape, any geometrical shape, into two similar shapes or two symmetric shapes or two congruent shapes like this. Now I'm talking about the isosceles triangle and the axis of symmetry of the isosceles triangle. Okay, if we have an isosceles triangle like this and we draw a straight line at the middle of the isosceles triangle like this, this line comes from the vertex angle up here and passes through the base of the isosceles triangle, and of course by using the meaning of the axis of symmetry which divide the shape into two symmetric shapes, then here this axis of symmetry divides the isosceles triangle into two congruent triangles like this. Then because those two triangles are congruent, then this line equal to this line, this angle equal to this angle, this angle equal to this angle, this line segment equal to this line segment, and everything in the right triangle equal to its corresponding in the left triangle. But now I need three properties from the axis made by the axis of symmetry of the isosceles triangle. The first property, this line bisect the base. Again, this line bisect the base. For example, if the base equal 10 centimeter, then the axis of symmetry divide this 10 into 5 and 5. Then we can say that the first property, the axis of symmetry bisect the base. In that case, any line comes from the vertex and bisect the base called median. Then this line has two names. The first name, this is the axis of symmetry of the isosceles triangle, and this is the median because this axis of symmetry bisect the base. The second property, because this line divide the vertex angle into two equal angles, then we say that it bisect the base like the vertex angle like this. Then the second one, it bisect the vertex angle or divide the vertex angle into two equal angles like this. For example, if the vertex angle equal 40, it divided into 20 and 20. The third property, it perpendicular to the base. Perpendicular, why? Because here we have straight angle. This straight angle divided by the axis of symmetry into two equal angles, then each of them will be 90 and 90. When the line makes right angle with the base or with the line segment, then it say that this line perpendicular to this line segment. Then the axis of symmetry here perpendicular to the base. Finally, the axis of symmetry do what? The axis of symmetry of the isosceles triangle do what? It bisect the base, bisect the vertex angle perpendicular to the base. In the questions, he will give me one of the three properties and I will conclude خلاص the two other properties. For example, if he give me that the line bisect the base as a given, then the conclusion, the two other properties, it bisect the vertex angle and perpendicular to the base. Another case, if he gave me that the line bisect the vertex angle, then I conclude that this line bisect the base and perpendicular to the base. And if he gave me this line perpendicular to the base in the given, then the conclusions that this line bisect the base and bisect the vertex angle. Okay, briefly we can say that he will give you 1 and you will take 2. Again, he will give you 1 and you will take 2. Okay, now let's study about the properties or the cases of these 3 properties like this. First, if he gave you that the line bisect the base like this, he gave you isosceles triangle and this line bisect the base. This is the given. Then the conclusion, the 2 other properties like this. It bisect the vertex angle. This is a conclusion. And it perpendicular to the base. This is the other conclusion. Okay, the given that it bisect the base, the conclusion that it bisect the vertex angle and perpendicular to the base. Another case, if the conclusion if the given that it bisect the vertex angle, then the conclusion, the first, this is the given, it bisect the vertex angle. Okay, the first conclusion, it bisect the base as we see here. The second conclusion, that it is perpendicular to the base as we see here. The third case, if the given that it perpendicular to the base, as we see here we have isosceles triangle and the line perpendicular to the base, this is a given, then the conclusion what? It bisect the base okay, and bisect the vertex angle. Okay, let's solve problems about this concept. Example 1 with us. AB equal AC as we see here, AB equal AC. BC equal 4 centimeters. Measure of angle DAC as we see here equal 35 degrees. Complete the following. Number 1, measure of angle BAD. Measure of angle BAD, because we have here isosceles triangle and we have one of the three corollaries. This one, okay, is this line perpendicular to the base. Then we get that this line is the axis of symmetry. This line, because this line is the axis of symmetry, then this line bisect the base, and this line perpendicular bisect the vertex angle. Okay, here we have 35 degrees, then the other angle also will be 35 degrees, then BAD equal 35 degrees. Number 2, measure of angle BAC, because BAC included 35 and 35. 35 plus 35 equal 70 degrees. Number 3, measure of angle B, because we have here right angle triangle. This line, this triangle, as we see, okay, this triangle included angle A equal 35, angle D equals 90, then angle B equals 180 minus open brackets 90 plus 35 degrees equals 55 degrees. Then the angle B equals 55 degrees. Okay. Number 4, BD equals what? Because BC equaled 4 centimeters and the perpendicular to the base bisect the base, then this one equal 2 and this one equal 2 centimeters. Number 5, the axis of symmetry of triangle ABC is what? This line AD is the axis of symmetry, but the word axis means straight line. Then when we write AD, we write AD like this and straight line above the line. Okay, let's solve the next one. Example 2. In the opposite figure, as we see here, AB equal AC, that means we have isosceles triangle, and AD perpendicular to BC. Okay, here we have AD perpendicular to BC. This is the given here. Okay, that make me know that this line is the axis of symmetry. Since this line is perpendicular to the base, then it is bisect the base and bisect the vertex angle. Again, this line perpendicular to the base, then this line bisect the base and bisect the vertex angle. Okay, now we need what? Number one, find the length of BD. Okay, to find the length of of BC, BD equal 5, and CD also equal 5, then BC equals 10 centimeters. Okay, I'm going to write this one by proof. Since AB equal to AC, and AD perpendicular to BC. Therefore, AD is an axis of symmetry. Of triangle ABC. Okay, therefore BC equals 5 times 2 equals 10 centimeters, because BD equals CD. Okay, the other required, find the area of triangle ABC. Okay, to find the area of triangle, we need the area of triangle equal half the base times height. Okay, now I need the height. The height here is AD. I need the length of triangle AD. Here we have triangle ADB is a right angled triangle. Again, here we see right angle triangle. Okay, in this right angle triangle, okay, we can find AD by using Pythagoras theorem, okay, as follow. Since in triangle ABD, since measure of angle ADB equals 90 degrees, therefore AD equal, here AD is a side in the hypotenuse, a side in the right angle triangle, and BD is a side, this one side, and this one is the hypotenuse. The side equal what? The side equal square root hypotenuse power of 2 minus side power of 2. Okay, then AD equal square root AB power of 2 minus BD power of 2, then AD equal square root 13 power of 2 minus 5 power of 2 equals 12 centimeters. Then AD equals 12 centimeters. Okay, in triangle ABC, I'm sorry, BC, which is the base, equal 10 centimeters, and the height, which is AD, equals 12 centimeters. Then area equal half times base times height equals half times 10 times 12 equals 60 centimeter square. The next example. Example 3 here. In this example, C belong to BD, as we see. Okay, measure of angle, this given means that this line, this angle is a straight angle. Okay, measure of angle ACD equal 130, measure BAE equal CAE equal 40 degrees, as we see here. Prove that number 1, AE perpendicular to BC. Okay, let's prove this one. Now we have here, okay, to prove that this angle is right. Okay, we studied before the meaning of the exterior angle of triangle. We have up here angle of measure 80 degrees, and here angle of measure 50 degrees. Then to find the exterior angle, we add the two interior angles except the adjacent. Then this angle equals 80 plus 50 equals 130 degrees. Okay, 130 degrees. We can use this concept here. Here we have triangle AEC. Angle ACD is exterior angle. Then we can find this angle 130 equal this number plus 40. Okay, then this angle equal 130 minus 40 equals 90 degrees. Okay, that means this angle is a right angle, therefore AE perpendicular to BC. This is the first required. Okay, since angle ACD is an exterior angle to triangle AEC. Therefore, measure of angle ACE, AAC equals 130 minus 40 degrees equals 90 degrees. Okay, I can find the 90 by other way. How come? By subtract 180 minus 130 give me here 50, and then in another step subtract 180 minus 40 plus 50, it will give me 90. Okay, but the exterior angle give me the answer in one step only. Okay, this is step 130 minus 40 equals 90 degrees. Okay, therefore AE perpendicular to BC, and this is the first required. The second required, prove that E bisects BC. Again, prove that E bisects BC. Okay. In this triangle ABC, since AE perpendicular to BC, and this is proof, and AE bisects angle BAC. That's because we have 40 and 40 here. Then this line bisect angle A. Therefore, AE is what? Is an axis of symmetry of triangle ABC. Therefore, E bisect BC, because the axis of symmetry, from its properties, it bisect the base. Okay, we can solve this one by many ways. We can make those two triangles congruent. This is a way. We can use prove that the interior angles, this triangle ABC is an isosceles triangle, but this is a very fast way that I prove that this line is the axis of symmetry by using that this line perpendicular to the base and bisect the vertex angle. The next one, the number of axes of symmetry. Now, if we have like this scalene triangle, in the scalene triangle I can't draw any axis of symmetry, and then the number of axes of symmetry is 0. If we have an isosceles triangle like this, okay, I can draw one axis of symmetry only, okay, from the vertex angle. Then we have here one axis of symmetry. But if we have like this an equilateral triangle, then I can draw 3 axes of symmetry like this. This is the first, the second, the third, and all of them intersect at one point. Now in this triangle we have 3 axes of symmetry, and they are in the same time the medians of this triangle, and in the same time they are the bisectors of the angles, and in the same time they are the heights. Okay, now the number of axes of symmetry of the equilateral triangle is 3. The next problem with us, example 4. In the opposite figure, AB equal AC, as we see. Now it's an isosceles triangle. BC equal 10 centimeters. Measure of angle BAD equal 30 degrees. AD perpendicular to BC, and all the givens appear in the shape. The first required with us, find the length of BD and the length of AD. Okay. The first required with us, here we have an isosceles triangle. This isosceles triangle included line perpendicular to the base. Okay, he give me this line perpendicular to the base. That means this line is, because of this given, then this line is the axis of symmetry, and we know, okay, the axis of symmetry bisect the vertex angle, then this angle is 30, then the next also is 30. Okay, and this line bisect the base. Okay, so if BC equal 10 centimeters, then we will divide the 10 into 5 and 5, and here this angle equal 60 degrees. But if we have isosceles triangle and one of its angles equal 60 degrees, then this angle is an equilateral triangle. That means angle B equal 60 and angle B equal 60. In that case, if we have an equilateral triangle like this, then AB equal 10 and AC also equal 10 centimeters because all sides are equal. Okay, the first required with us, I need to find BD. BD, as I said, equals 5 centimeters. Okay, since AB equal AC and AD perpendicular to BC, therefore AD straight line, don't forget, is an axis of symmetry of triangle ABC. Therefore, BD equal CD equal 10 divided by 2 equals 5 centimeters. Okay, we can see that AB equal 10 centimeter by two different ways, or we can prove that this equal 10 by two different ways. The first way that I explain or prove that this triangle is an equilateral triangle, or the second way by using triangle ABD, which is 30-60 triangle, then the side opposite to the 30 equal half the hypotenuse, and this is the other way. I will prove that this triangle is an equilateral, okay, because I need this one. Therefore, also measure of angle BAD equal to measure of angle CAD equal 30 degrees. Therefore, measure of angle BAC equal 30 times 2 equal 60 degrees. Therefore, triangle ABC is an equilateral triangle. Therefore, AB equal BC equal AC equal 10 centimeters. Okay, in triangle ABD, since measure of angle D equals 90 degrees, therefore AD equals square root, of course side equals square root hypotenuse power of 2 minus side power of 2, which is 10 power of 2 minus 5 power of 2 equals 5 square root 3. Okay, the next required. How many axes of symmetry? Okay, because the triangle is equilateral, therefore triangle A B C has 3 axes of symmetry. Okay, the next required. Find the area of triangle ABC. Now, to find the area equal half the base times height. Therefore, area of triangle ABC equals half times base times height, which is equal half times 10 times 5 root 3, which is equal 25 square root 3 centimeter squared. Okay, and this is the end of this question. The next one. Now we studied the axis of symmetry of the isosceles triangle. Okay, and now I'm going to study the axis of symmetry of the line segment. Okay, if we have a line segment like this, okay, the axis of symmetry of a line segment is a straight line at the middle like this. This straight line has two properties. The first property is that this line bisect the line segment, okay, like this, or divide the line segment into two equal halves. Okay, the second property, that this line perpendicular to the line segment as we see. Then if he asks me the axis of symmetry of a line segment do what, then I say it bisect the line segment and it perpendicular to the line segment. And all of us know what the meaning of bisect and perpendicular to the line segment. But if I ask you in another meaning, the perpendicular to the line segment from its middle, or the perpendicular bisector of the line segment, is called what? It is called, you will answer, it's called the axis of symmetry of this line segment. Then we can ask the question by two different ways. Okay, type. Now if we have the points of the line segment A, here A and here B, and here in the middle the point M, that means the point M, which belongs to the axis of symmetry, lie at the same distance from A and B, or by another meaning MA equal MB. If we have another point C and we draw C, B and CA, we get that CB and CA are equal, or we can say that C lie at the same distance from A and B. If we have a third point D and we draw DB and DA, we get that DB and DA are equal, as you see. If we have a fourth point E and we draw EA and EB, then we get that EB and EA are equal. I can, okay, say that any point that belong to the axis of symmetry of a line segment lie at the same distance from its terminals. Terminals means outer points. A and B are the terminals of the line segment. Then any point belong to the axis of symmetry is at equal distance from its terminals like this. Every point lie on the axis of symmetry of a line segment is equal in distance from its terminals. Terminals means outer points, or A and B. A and B are the terminals of the line segments. It's clear. Now, again, the axis of symmetry of a line segment bisect the line segment and perpendicular. And if we have points belong to the axis of symmetry of a line segment, then they lie at the same distance from its two end points or terminal points. Okay, let's solve the next one. Here we have example 5. In this example, as we see here, AB equal AC equal 10 centimeters, AB equal EC, okay, AE intersect BC at D, as we see. Prove that BD equal DC and BD, and if BD equal 6 centimeters, find the length of CD and AD. Now we have three required. The first required with us to prove that BD equal CD. Okay, it's very easy, since AB equal AC and EB equal EC. Therefore, since A lie at the same distance from B and C, and E lie at the same distance from B and C, then AE is the axis of symmetry of BC. Therefore, AE, and of course I will write straight line up, is the axis of symmetry of BC. Okay, now since this line is the axis of symmetry, then it bisect the line segment and perpendicular to the line segment. Again, the axis of symmetry bisect the line segment and perpendicular to the line segment. Okay, now the second required. Okay, BD equal 6 centimeters. Therefore, of course, I forget to write this. Therefore, BD equal to DC. Okay. Now, if we have BD equal 6 centimeters, BD equal 6, then CD equal also 6, and AB equal 10. Now I need to find CD. CD equal 6 centimeters. Therefore, CD equal 6 centimeters. And I need to find AD. Okay. I say before that if we have a right angle triangle, here we have ADB is a right angle triangle in triangle ABD. Since AD perpendicular to BC, and this is because this line is an axis of symmetry. Therefore, AD equal what? Here, this line is side, and this one is side, and this one is a hypotenuse. All of us know that the side equal square root hypotenuse power of 2 minus side power of 2. Then AD equal square root AB, the hypotenuse power of 2, minus BD, the side power of 2, which is equal 10 power of 2 minus 6 power of 2, which is equal 8 centimeters. Then AD equals 8 centimeter, and this is the third required. Okay, the next one. Example 6 with us. in the opposite figure as we see here. ABCD quadrilateral, AD parallel to BC, okay. BD bisects angle ABC as we see, and AE bisects angle B. Okay. Okay. First, prove that AB equal to AD. Okay. Now I need to prove that AB equal to AD, or I need to prove this triangle is an isosceles triangle. It's very easy. Here we have parallel lines, this line and this line. And I will highlight the transversal BD like this. Excuse me. Now we have Z shape as you see. Okay. Okay, now we have Z shape. Then I can reflect this angle from here to here. Then this angle equal to angle DBC. Okay, since those two angles are equal in measure, DBC and DBA, then angle DBA equal to angle BDA. Therefore, the triangle is isosceles triangle, triangle ABD. Okay, and here we have isosceles triangle in which this line bisects the vertex angle, then this line is the axis of symmetry. Okay, now I will start to prove the first required, AB equal AD. Okay, since AD parallel to BC, therefore measure of angle ADB equal to measure of angle DBC, and of course this is alternate angles. Okay, and I will call this one relation 1. Since BD bisects angle B, therefore measure of angle ABD equal to measure of angle DBC. This is number 2. By looking to 1 and 2, ADB equal DBC and ABD equal DBC, then DBC is common in both cases. Therefore, from 1 and 2, therefore measure of angle ADB equal to measure of angle ABD. Therefore, triangle ADB is isosceles triangle, or we can say directly AB equal to AD. This is the first required. The second required with us, prove that AE perpendicular to BD. As we said before, since we have isosceles triangle and this line bisect the vertex, then this line is the axis of symmetry which is already perpendicular to the base. Okay, since AE bisects angle DAB, therefore AE is the axis of symmetry, or I can say AE perpendicular to BD directly. The third required with us, prove that EB equal to ED. Okay, since this line is the axis of symmetry, therefore AE bisect the base. Okay, therefore AE excuse me, therefore ED equal to BE, and this is the third required. The next example. In this example, number 1, the straight line drawn from the vertex of isosceles triangle. This is the first required. We have isosceles triangle and perpendicular to the base is called axis of symmetry. The next required, the number of axes of symmetry of the equilateral triangle is 3. The number of axes of symmetry of the isosceles triangle is 1. The number of axes of symmetry of the scalene triangle is 0. The median, this is the first required of isosceles triangle, this is the second required, drawn from the vertex angle. Okay, here we have three conclusions, three corollaries. That the median, which bisect the base, and the second one bisect the vertex angle, the third one perpendicular to the base. He gave me that it is the median. Then I will write the two other corollaries that are bisect it. It here means the vertex angle and perpendicular to the base. Number 6, the bisector, this is the first required, of the vertex angle of isosceles triangle. It do what? Bisect each of the base bisect the base and perpendicular to it. Of course, each of, again, it bisect the base and perpendicular to it. The next example, the next one, number 7, the straight line passing through the vertex of isosceles triangle and perpendicular. Okay, here we have perpendicular to the base. Then I will write bisect the base and bisect the vertex angle. Note that you have to write vertex angle. not vertex only. Okay, number 8. Any point belonging to the axis of symmetry of a line segment is what from its terminals is at equal distance from its terminals. And this is the end of the lesson. I hope it was helpful for you. See you in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.